Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. And I am Jeetendra Dixit. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. So we were doing sequence and series in this session, right? I mean in this slot. And today we are going to start geometric progressions. So I've already taken 2 sessions on arithmetic progressions in which we did general term of arithmetic progression and summation of arithmetic progression. So we'll finish geometric progressions in next 2 sessions, and after that we'll practice some more questions on arithmetic and geometric progression summation. All right, series is. So before starting, let me once check my voice. Let me check my voice. Before starting, let me. Yeah, perfect. All right. Okay. So also before starting today's session, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform, and when you get subscription for IIT-JEE, okay, I'm talking about IIT-JEE because you can prepare for many exams on this platform, like NEET or UPSC or SAT or whatever exam you can think of, all right, or CBSE also, boards. So if you are preparing for IIT-JEE and if you get subscription of IIT-JEE on Unacademy, then what are the things you will be able to access, or you get. Let me explain those things first of all. So first of all, let me tell you about the daily live classes. Okay, so when you are preparing for IIT-JEE, then you prepare for physics, chemistry and maths. So all the educators who are teaching for physics on Unacademy's platform, physics, chemistry and maths, you will be able to access those educators. You can watch their live sessions every day. All right, unlimited live session, there's no restriction, you can follow any educator, and you can also watch their recorded sessions. All right, so lectures which are already been held, you can watch those sessions later also. So this is the unlimited access you get once you get the subscription. All right, and you know, India's top educators are teaching on Unacademy's platform, so you are getting, I mean, access to all the educators by getting just one subscription. Apart from this, the things which you get without getting subscription are basically special classes. So special classes you can attend as many as you can. All right, on the platform every day, so many special classes are going on of the same educators. Every educator take special classes once or twice in a week, or maybe more than that. So you can attend their special classes on various topics. These classes are completely free, so unlimited special classes you can attend. And by attending the special classes, you will come to know how interactive this platform is. I mean, you can easily interact with your educator through chat. You can participate in poll. You can send your doubts. So there are dedicated doubt clearing sessions as well on the platform. Even in special classes, we keep doubt clearing sessions. All right. So these are the things you get without even getting the subscription. Live tests and quizzes are also live quizzes basically. Live quizzes are very special feature of Unacademy's platform. You can attend unlimited live quizzes happening on this Unacademy's platform, which are also free. All right, but the tests and quizzes which we conduct on Plus platform, those tests and quizzes you can attend after taking subscription. All right, so all these courses are well structured on Unacademy's Plus platform. All right, that means you get to know the upcoming schedule of all the upcoming lectures in well advance. You can see which particular lecture will be on which date. You can see that in the schedule of every educator. So this was about the subscription, and you can download Unacademy's learning app from Play Store, and after downloading you can subscribe for 1, 3, 6, 12 and 24 months, and these are economically better packages. That, I mean, you can compare the average price per month. Okay, so it is decreasing and it becomes lowest in 24 months subscription. All right, so for 24 months you will have to pay 50,400 after 10% discount if you use this code JEET1. So use this code JEET1 and you'll get 10% discount. All right, and for 1 year also you can use this code and you'll get, so in all the subscriptions, if you use my code JEET1, then you'll get instant 10% discount. All right, So this was about the subscription. Now let's begin today's session, sequence and series. All right. So what is geometrical progression? So geometrical progression. All right. So if ratio of two consecutive terms of a progression or of a sequence is constant, if ratio of two consecutive terms, that means if your sequence is defined as like an is the nth term, this is your sequence, all right. If you remember sequence, you write general term in curly brackets, all right. So this is a short form of representing a sequence. So if an upon an minus 1, that means nth term upon n minus 1th term is constant. If this is a constant, all right, then sequence Sn is called geometric progression. Okay, so if ratio of two consecutive terms is a constant, then the sequence is called geometric progression. Yeah, yes, Jay, you're right. Absolutely correct. So let first term is and this ratio is this constant common ratio. This ratio is called, if you take it R, this is called common ratio, like common difference in AP. It is called common ratio in GP. So let first term, let A1 is equal to A and common ratio is equal to R. Then you can form this GP. First term will be A, the next term will be the A into R. Okay, you need to multiply this common ratio to previous term to get the next term, all right. So it is AR, the next term will be again multiply R to previous term, that means this term. So it is going to be AR square, then AR cube and so on, right. So this is the geometric progression. Can you write, using this symmetry, can you write the nth term? So what will be the nth term? Let's write it. You can see second term, the second term is A into R raised to 1. Third term is AR square. You need to put 2 power, okay. Fourth term is AR cube. So similarly, nth term will be AR raised to n minus 1, okay. So this is the formula for nth term of a GP. Nth term of a GP. All right, and R cannot be 0. Remember that R cannot be 0. So term of a GP, no term of a GP can be 0. Remember that. No term of a GP can be 0. So in general, let me write it here. AN cannot be equal to 0 for any n. For any value of n. Okay, so GP has non-zero terms. Non-zero terms in AP term can be 0, but in GP it cannot be. Otherwise, you can see the ratio will not be defined. If you take ratio of an upon an minus 1, and if you take any of the terms 0, then that will go in the denominator and it will be non-defined. Okay, so no term of the GP will be 0. Common ratio still cannot be 0. All right, so I hope these points are clear. Now let's write some important points about GP. Okay, so important points, or you can say properties. First of all, if A, B and C, 3 terms, okay, see, and A, B, C belong to real numbers and except 0, as I told you just now. So if A, B, C are in GP, then what will be the relation? You can write B upon A is equal to C upon B, all right? Then this will give you the relation B square is equal to AC. Like in AP, if 3 numbers A, B and C are in AP, then you write 2 times of middle term is equal to first plus last. But in GP, it is a square of the middle term is equal to first into third. So B square is equal to AC. I hope it is clear. So this is a very first point. Okay, and very important. So whenever you need to prove that 3 numbers are in GP, you just square the middle term and that should be equal to the product of first and third. And if this happens, then you can say these 3 numbers are in GP in this particular order, A, B and C. Okay, order will remain same. You can't interchange the order. You can't write A, B, C are in AP, GP, then A, C, B will also be in GP. No, that is not correct. Okay, that is not correct. Now next point is, next point is again very important. If A1, A2, A3 and so on, AN minus 2, AN minus 1, AN are in GP. So if your n numbers a1, a2, this is a sequence, or you can say progression, geometrical progression, all right, then you can say that first into last, okay, first into last is equal to second into second last is equal to third into third last, all right, which is an minus 2. So can you see this? What am I writing? Actually, I'm writing this first into last. First into last is equal to second into second last. What will happen? Because if you see an in an minus 1 and an, what is the relation? An minus 1 is an upon r and a2 is a1 into r. So if you multiply them, then ar and ar will get cancelled, and an into a1 will become equal to an minus 1 into a2. All right. So in the similar way, you can write third into third last and so on. The third term is this was a3 into an minus 2 and so on, a4 into an minus 4. And how to generalize it? Rth term from the beginning is ar, and what is the rth term from the last? Do you remember that? An minus r plus 1. Okay. In AP, I told you this thing that first plus last is equal to second plus second last is equal to third plus third last. In GP, it is first into last is equal to second into second last. It is equal to third into third last, and rth from the beginning into rth from the end. So you can generalize this. All right. So in this way, you can generalize it. This is a very, very important property, and we use it in very good questions. All right. So remember that. Now next point is same, if a1, a2, if a1, a2, a3 and so on separated by comma are in GP, then if you multiply a constant ka1, ka2, ka3 and so on, kan, okay, where k is a non-zero number, k is not equal to 0, or you can say k belongs to r minus 0. That's a better way. Any real number except 0. Then these numbers will also be in GP, will be in GP. That means if you multiply a constant to all the terms of a geometric progression, then the new progression you get is also a GP with same common ratio, with same common ratio. So let's take common ratio of this is R1, that will be Kan upon Kan minus 1, that is An upon An minus 1, and let's say common ratio of this is R, all right, then this is equal to R, all right. So R1, common ratio of this is equal to common ratio of this sequence, original one. So I hope this point is clear. So if you multiply a constant to all the terms of a GP, then terms will remain in GP. Even if you put power n, a1 raised to n, a2 raised to n, a3 raised to n, all right, any power, an raised to n, okay, positive or negative, doesn't matter. Then also terms will remain GP. These terms are given in GP. I'm using the same point, a1, a2, a3, a up to an are in GP. Then a1 raised to n, a2 raised to n, a3 raised to n, and an raised to n, or you can put m, not necessarily m. Let's take, okay, m. Don't get confused with this m, okay? So m can be any number. Power m, then are also in GP, with common ratio. Let's take common ratio of this R1. So that will be an upon an raised to m upon an minus 1 raised to m. So you can write that an upon an minus 1 whole raised to m, and that is common ratio r raised to m, all right, r raised to m. So I hope this point is clear. Common ratio will be now different, but terms will remain in GP. Even if you square all the terms of a GP or cube all the terms of a GP or put minus 2 power of all the terms of GP, all right. So I hope this point is clear. Now another point is, this is very important. If you take log of all the terms of a GP with same base, okay. So I'm taking natural log, you can take any base. Okay, let's take C. So A1, A2, A3, then what will be this new sequence? If you take log of all the terms of a GP, this is a very, very important point, and this they ask in many questions, all right. So when you take log of all the terms of a GP, then new sequence you get will be in AP, will be in AP. So now let me explain this. Let's take A1, A2, A3 as, um, I'll tell you the proof of this. So A1, this is your GP, AR, AR square, AR cube, all right, and so on, AR raised to n minus 1. Now take log. So now take log to the base C, and see what will be the new common ratio if it's a GP. First of all, let's check whether it's a GP or not. And if it is a GP, then we'll check what will be the common ratio. So now your series is going to be log of A, then log of AR, then log of AR square, and so on, log of AR raised to n minus 1. Now after taking this log, let's rewrite these terms again. So log of AR can be written as log of A plus log of R, okay, using the property of log. Log of AB is log of A plus log of B, all right. Then this will be log of A plus log of R square, which is 2 log R. So I hope you're getting this. And C, up to this will be log of A plus n minus 1 into log of R. Now if you see the difference of these two, it's log R, difference of these two is log R, right? Common difference, okay? So, or you can say first term is log A, second term is log A plus log R, the next term is log A plus 2 log R, the next term will be log A plus 3 log R. So have you got it? This common difference is constant of two consecutive terms. So now these terms are in AP with common difference. What will be the common difference? Okay, let's take base C also, C. So it will be generalized. If you take base C, then C will be everywhere, okay? Log, we are taking log with base C. So what will be the common ratio? So common difference of this AP is log, okay, let me write it here. So common difference is going to be log of R to the base C, all right? We are forming AP. So I hope these properties are clear to everyone, but let me also remind you, if you add a constant, like in AP you added a constant and subtracted a constant, then the sequence was same. Numbers were in AP only, but in GP that is not true. Even in GP, if you add some number, then numbers will not form a GP, and it won't form even AP, right? Like by taking log, you can say they are forming AP, but by adding some number, adding some constant to all the terms of a GP, it won't be any specific sequence in general always, all right? So I hope these points are clear. But you can multiply, right? Multiplication property is same. If you multiply a constant to all the terms of a AP, they will remain in AP. If you multiply a constant to all the terms of a GP, it will remain a GP. Okay? The multiplication property is common. Okay, log is different. So like log, if you put all the terms of an AP to the exponent, okay, let me tell you that property here. It's a inverse of log. If I say A1, A2, A3 and so on up to AN are in AP. So let's take numbers like this. A plus D, A plus 2D and so on. A plus N minus 1 into D. Okay, this is AP. Then if you put these numbers on the power of some constant or exponent, right? So let's say B is the number. B is a positive number, then B raised to A, B raised to A plus D, B raised to A plus 2D, all right, and so on, B raised to A plus N minus 1 into D. So if you are putting this these numbers which are in AP on the power of some constant B, positive constant, the new sequence formed is GP, okay? So now these numbers will be in GP. So like if you take log of terms of GP, it becomes AP, and if you take anti-log, that means if you put terms of AP to the exponent of some constant, positive constant, then it will become GP. Okay, so these two are very, very important properties of AP and GP. So I hope these points are clear. Now one very, very important point again, If you need to select, three numbers, three numbers in GP, 3 or 5 or 7, okay, odd numbers, three numbers in GP. Then you can take numbers, obviously you can take AR square, okay, or you can take A upon R, A and AR square, AR, sorry, AR. These three numbers are, so I'm starting with A upon R, okay. This will be helpful, this is useful if product of the numbers is given. If product of the numbers is given, all right. So if product of the three numbers, suppose you have a question based on like find three numbers which are in GP whose product is this and summation is this, then you should choose three numbers A upon R, A and AR, because if you take the product of this, you can see R will get cancelled, you'll get directly A if product is given. But if product is not given, then you can take AR square, okay. Similarly, if you need to take five numbers, if you need to take five numbers, if you need to take five numbers, then what will be the five numbers and product is given, okay, five numbers, let me write five numbers. So you can take AR square, AR cube and AR square, A raised to 4. There is no problem by taking these numbers, okay. Or you can take A upon R square. Now start from A upon R square, then A upon R, then A, then AR and then AR square. And this will be useful again when product of the numbers is given, all right. Same logic. If product is not given, then you can take these numbers as well, right. So mostly you need to take three numbers. Sometimes it might be 5 also or 7, or similarly in 7 also, if 7 numbers you need to take and product is given, then you take the last number and you increase one number in last of this, that will be AR cube, and one number before AR square, that will be AR cube, okay. So let's start from AR cube, A upon R cube. So I hope this point is clear. But if you need to take even number of terms, like 4 numbers in GP, 4 numbers in GP, then again by same logic you can take AR square, AR cube. And this you can say common ratio. So far common ratio is R, right? In all the numbers which we have taken in GP in previous slide as well as this. But if product is given, then we'll take not in this form, or you can take in this form, AR and then A upon R. Now you won't take A. It will be AR and A upon R. So you can see if these two are consecutive terms, then common ratio will be R square. So next term will be AR cube and previous term will be A upon R cube. So these are 4 numbers in GP and this will be useful if product of the numbers is given, okay. So just focus on my point that if product is given, then you need to take these numbers, and remember, don't make this mistake, common ratio is R square, okay. Common ratio of these numbers is R square, not R, okay. So if you need to find common ratio in the end, then don't write R is equal to, if you're getting R is equal to 3, then common ratio is 3. Common ratio will be 9 then, okay, if you're getting R is equal to 3. So I hope these points are clear. We'll discuss summation of GP, summation of series of geometric progression later. Let's do some practice questions before that. So this is the first question. Try this one. Okay. So try this sum. Try for a minute, then I'll tell you. Very, very easy problem. Okay, Sakshi, hello. How are you? So you have written C. All right, let's see. Anyone else getting the answer? Anyone else? All right, so yes. So actually, let's see. 4 raised to 5 you're getting, okay? So if you have 5 numbers, then A1, see, first I'll tell you two methods. Okay, so method 1, using the property A1, A2, A3, A3, A4, A5, all right? So in GP, or in GP, so you know first into last is equal to second into second last, but you have odd numbers, so this is the term in the middle. Then if you have one term in the middle left, then it will be square of that. That means you can write A1 into A5 is equal to A2 into A4 is equal to A3 square, all right? And A3 is given, so third term is given 4. So A3 is given 4. You need now you need to find this value a1 into a2 into a3 into a4 into a5, right? Okay, so you can write this product is going to be, so this is going to be 6, this is now 4 square, so you can put the value of these two, 4 square 4 square, so it is 4 square 4 square and a3 is 4. So yes, your answer is correct, Sakshi. 4 raised to 5. So answer is 4 raised to 5. All right, this is method 1. Now let me tell you method 2. Suppose you mm, forget this property and you are not able to apply, or maybe it doesn't come in your mind. Then you can directly go like first term A1 is equal to A and common ratio is equal to R. Let's take this. Then you can write third term is given. Third term is given. So third term is AR square is given. AR square is given 4. Now you need to write the product of first 5 terms. So that will be AR square, AR cube, AR raised to 4. You can write this product. This is something you need to find. Okay, so after simplifying, you can write this is A raised to 5 into R raised to how much? 1 plus 3, 6 plus 4, 10. Okay, then you can write this AR square whole raised to 5, right? And A square is given. So that this given information will be useful. Directly use it. You don't need A and R separately. Okay, directly use it. So it is 4 raised to 5. We can't find first term and common ratio individually, but we can find this product, right? I mean, you can't find the you can't find the terms of GB, but you can find this product at least. So that is 4 raised to 5. Okay, so without using property also you can complete it. I hope it is clear. Now let's move to another problem. Try this one. It is very simple. The first point, important point, which I have written 3 terms in GP, then what to do? Apply that. Apply that. It's a very, very easy problem. Questions are like board levels today. We'll upgrade level slowly. Beginners level, you can say. Okay, so because 3 terms are in GB, so you know, if A, B, C, if A, B and C are in GB, then B square is equal to, AC, right? So hence you can apply that 2x plus 2 the whole square is equal to x into 3x plus 3, all right? Then simplify it. It is going to be 4x square plus 4 plus 8x is equal to, it is going to be 3x square plus 3x. Okay, so now it is x square plus 5x plus 4 is equal to 0. So you will get x So what is your x? So x is equal to either -1 or -4. All right. So -1. So can you take -1 or -4 both, or what will happen? Let's see. If I take -1, then I'll get first term as -1. Okay. If x is equal to -1, then first term is -1 and second term will become 0. Oh, did you get that point? I told you that no term of the GP can be 0. So that means this -1 is rejected. Okay. So because of this 0, x cannot be -1. Okay. So we will reject this. I hope it is clear. All right. So x cannot be -1. Then what is remaining? That means x is equal to -4 can be the another value, right? So if x is equal to -4, then terms will be -4, then -8 plus 2 is -6, then -12 plus 3. Okay, so -12 plus 3 is -4 minus what is this? -9, right? -9. So what is the common ratio? Let's find the common ratio. So common ratio is -6 upon -4 or -9 upon -6. Check it. They should be same. So yes, it is 3 by 2. Then this is also 3 by 2. Okay, if you cancel 3 by 2 and 3 by 2. So common ratio is nothing but 3 by 2. So you got the common ratio. This is your first term. So you need to write which term? Fourth term. So A4 is equal to first term, which is -4 into common ratio raised to 3. So put the value of common ratio. Common ratio is what? 3 by 2. So 3 by 2 raised to 3. So what is this going to be? 3 into 3 into 3. 27 divided by 2 with minus sign. So yes, which one? 13.5 but with negative sign. With negative sign. This is your answer. All terms of a GB can be negative. No problem, because first term is positive, and if first term is negative and common ratio is positive, in this case, like in this case, first term is positive and common ratio is negative, then all terms of the GP. See what happens in GP. If A is positive and R is negative, okay, then terms will be positive, negative, positive, negative, positive, negative, alternate, okay, terms. Okay, alternate plus minus. That cannot happen in AP. In AP, either terms are consecutively positive and then they can become negative, or they can be entirely positive or they can be entirely negative. Okay, but in GP terms, if some terms are positive and some are negative, then terms will be alternate plus minus. And if A is positive and R is positive, then all terms will be positive, right? All terms will be positive. And if A is negative and R is positive, then then all terms will be negative, right? AR square, AR cube. So because of this A, all terms will be negative. All terms will be negative. Getting this? All terms will be negative. Okay, so don't get surprised if you see some positive, negative, or all negative terms in a GP. Don't get surprised. It can happen. Now this is the next term. Try it. Which term is this? Do it. It's an easy problem. Very easy. Got it. Okay. Subhash, Sakshi, okay, 8. Okay, both of you are getting 8. All right. How are you, Subhash? Okay, so first term is given 18. All right, let's write the common ratio. So common ratio is minus 12 upon 18. Okay, also check this 8 upon minus 12. Na? By mistake, just check whether it is GP or not. All right, so take common ratio of at least uh, first, second, and third and second also. Na? So only 3 terms are given, so that's what only we can check. So this is going to be what? Minus 12. So it is going to be 2 upon 3. So minus 2 upon 3. All right. So this is your common ratio. Now apply the formula. So A, which term? 10th you need to write, which, okay, you need to find. So nth term will take, nth term is A into minus 2 upon 3 raised to n minus 1. All right. So that should be equal to 512 upon 729. All right. So one thing is for sure. Let's see. Write this in terms of minus 1 raised to n minus 1. Write it separate. And n minus 1 should be even. That means n must be odd. Okay. So by that only you can eliminate. Oh, so actually you have changed your answer. Huh? So now it is going to be, this is going to be 2 square. This 18 is 2 square. Sorry, 2 into 3, 2 into 3 square. So you'll get 2 raised to overall n, and 3 raised to, it is n minus 1, and in numerator it is 3 square. All right. So I'll write it again. 512 upon 729. Now you can write it is 2 raised to n in the numerator. Yeah. 2 raised to n in the numerator upon 3 raised to n minus 3 and minus 1 raised to n minus 1. All right. Let me check it again, the calculation part. Okay. So it is equal to 512 upon 729. So if you compare, then what is 2 raised to 2 raised to 9 is 5. 2 raised to 9, फिर 2 raised to 9 is equal to 512. 2 raised to 5, 6, 7. 2 raised to 7 is 128. 2 raised to 8 is 256, and 2 raised to 9 is this, right? So compare. So and also check, if you put n is equal to 9, it will be 3 raised to 6, and 3 raised to 6 is this number, right? You can write this 2 raised to 2 raised to 8, sorry, 2 raised to 9 upon this is 7 raised to 6, 3 raised to, sorry, 3 raised to 6, because 3 into 3, 3 raised to 4 is 81, then 3 raised to 5, 6, yeah, 3 raised to 6, perfect, 3 raised to 6. You can compare, so n will be equal to 9. If n is 9, then this will become a positive number, and these two will be equal. So n is equal to 9, you can compare. So yes, ninth is the correct answer. All right, Subhash, your answer is wrong. Okay, try this. Try this. Total number of terms in the progression is निकालना है. ये first term is given and the last term is given, and the common ratio you can also find. So you need to find, it's a similar question like the previous one. Last term was given in that also, and you just try this also. Rombo n, you are getting n, 10, and A and B, we are getting A and B options. All right, let's do it fast. So first term A is going to give me 96. Let's take common ratio as R. So you can write 96 into R. Okay, so R is equal to what? R is equal to 48 upon 96, right? Or you can write 24 upon 48, or you can write 12 upon 24, right? Any one of this. So what is this value? So this is 1 by 2, right? 1 by 2. So common ratio is nothing but 1 by 2. So common ratio we have got, so R raised to number of terms, let's take n minus 1, n, sorry. So last term, nth term is given what? 3 by 16. So equate with 3 by 16. Now it is going to be 1 by 2 raised to n minus 1 is equal to, now just divide by 96. So it will be 3 upon 96 into 16, okay? Cancel this. So it will be 32, right? 32. So you can write in terms of 1 by 2 raised to, this is 5 and plus 4, so 9, right? Yeah. This is what? 2 raised to 5, 2 raised to 4, 2 raised to 9, right? Compare it. So n minus 1 is equal to 9. So n is equal to 10. Yes, Rombo, your answer is correct. N is equal to 10. Subhash, you have again solved it incorrectly. Easy problem. All right. Try this one. Third and seventh term of a GP are given, then find the fifth term. I'm giving you very easy problems. Do it correctly, guys. This is a very good problem. I'll tell you a shortcut for this, which you can apply and find the answer directly. Try this. You first try it, then I'll tell you the method, another method. I'm sure that is going to be a good, better method. All right. Done, guys. Okay. C. Okay, both of you are getting C now. Let's check. So if you take this sequence A1, A2, A3, A4, A5, A6, A7, how many terms are given? 7, A8, and so on. Let me tell you one thing. If you take these consecutive 3 terms, then this middle term will be, this square of middle term will be equal to first into third, right? Even if you take first and fifth term, then product of this will be equal to square of this term middle. This will be in the middle, right? A3 square. Okay, even if they take first and seventh term, then that will be, which is the middle term in this? A4. A4 is the middle term. You can see 2 terms, you leave these 2 terms and these 2 terms. So A4 is in the middle of A1 and A7. So if you multiply A1 and A7, that will be equal to square of A4. Okay, or you can say A1, A4 and A7 will be in GB. Okay, so if you take terms with equal gaps, they will also be in GP. So similarly, third, seventh, and you need fifth. Third and seventh are given. So third, fifth, okay, let me write it again. A1, A2, A3, A4, A5, A6 and A7. Look at this. Third, fifth and seventh. Okay. These three terms are with equal gaps. Just leave this term and leave this term. Right. So that means product of third and seventh will be equal to square of this. That means A3, A5, A7 are also in GP. A3, A5 and A7 are in GP. Okay. You can say that if they have equal gaps. Like that you can apply for say 10th term, 15th term and 20th term. Okay, you can apply for that also. If your 10th term is given and 20th term is given, that you can then you can find A15th easily. Okay, A15th will be the geometric mean of these two. So A5 is geometric means, that means A5 square is equal to A3 into A7, and this is 15 into 135. Okay, this is 15 into 9, right? So A5 is equal to what? 45. Okay, this is the 5th term. Even it can be minus 45 also, but that is not given. So this. Okay, because alternate terms can be positive, negative, positive, negative. I told you, right? So 15 and this. No, sorry, minus 45. This is 3rd and 5th. 4th is there. So 3rd is positive, 4th can be negative, 5th will be positive only. So answer will be only 145. That's it. So I hope this is clear, right? Got this method? I hope it is clear. Let's move to another problem then. Now, first we will discuss the summation of GP. So, sum of n terms of a GP. Okay, so I'll tell you the formula for n terms of a GP. Method is important because the same method we are going to apply in any series which has like you can multiply AP GP, you can multiply AP GP, you can multiply GP with some other sequence. So in any such series, you will apply this method to find the sum, which we are going to apply in this GP. Okay, what is the method? Suppose AR square, this is our GP, so we need to add these terms AR square plus AR cube and so on up to AR raised to n minus 1. All right, so this is the sum. Now you need to multiply this whole equation by the common ratio of GP. Always do that whenever you have a GP or some other sequence into GP. Okay, just figure out the common ratio of GP, multiply that common ratio to the equation and subtract with the given equation. Okay, when I'll multiply this R to right hand side, I'll write this first term will become AR. I'll write AR below this AR. Okay, this second term will become AR square, so I'll write AR square. That means I'm shifting this series by one term, and this AR square will become AR cube and so on. The previous term is AR raised to n minus 2. Now it will become AR raised to n minus 1 plus AR raised to n, the last term. Now subtract it. After subtracting, what will you get? What will you get? You are going to get the formula. This is 1 minus R into S is equal to, if you subtract, all these terms will get cancelled. All these terms will get cancelled, right? And you'll get A first term and this term with minus sign because you are subtracting this series. So AR raised to n. So S is going to be A into 1 minus R raised to n upon 1 minus R, or you can take minus common from numerator or denominator. So you can write A into R raised to n minus 1 upon R minus 1. But one thing is for sure, this formula is not valid when R is equal to 1. So make sure that R is not equal to 1. So what will be the answer if R is equal to 1? If R is equal to 1, then what will be the answer? If R is equal to 1, then all terms will become A, right? So you are adding A n times, that is n times of A, alright? So if R is 1, then all terms are equal. All terms are equal, then you can add them easily, like 2 plus 2 plus 200 times is 100 times of 2. Similarly, A plus A plus A plus A n times is n times of A. So if common ratio is 1, then answer is n. If common ratio is not 1, then you can apply that formula, AR raised to n minus 1 upon R minus 1. Now, in GP, we also find the sum of infinite geometric progression. Why infinite terms? Why haven't we done that in arithmetic progression? Because in arithmetic progression, if you take infinite number of terms, then their sum will not be finite. It will be infinite. It will keep adding some number or keep subtracting some number. So it will be either plus infinity or minus infinity if numbers are negative. But in geometric progression, it is not so. Why? Let me explain that. if common ratio, there's a condition on common ratio. If common ratio of a GP R is less than mod of R is less than 1. Okay, so if common ratio is less than 1, then you can see these terms. If A, say R is 1 by 2 and A is 10, then this will be 5 by 2. The next term will be 5 by 4. The next term will be 5 by 8. If A is 5, R is 2, then A is 5, then AR is 5 by 2, then 5 by 4. Then you can see 5 by, this will be 8, right? And you can see this, these terms are decreasing drastically, exponentially, you can say. Now, if you take, let A is equal to 5 and R is equal to 1 by 2. Take this example and let's understand it. 5, then it is 5 by 2, then it's 5 by 4, and it is 5 by 8, and this is 5 by 16. And later, if you take 100 or 100th term, it will, or 101th term, it will be 5 upon 2 raised to 100, which is very, very small, very, very small. So you can see as you're increasing number of terms, then terms are approaching to 0. It will always happen whenever your common ratio is less than 1. If common ratio is not less than 1, then term will increase, and term will increase exponentially. Okay, then you can't find the sum, because it won't converge. In what it won't converge to a finite number, it will be a divergent series. This divergent and convergent we use when the summation of a series is bounded or unbounded. That means when it is approaching to a finite number, it is bounded, and if it is not approaching to a finite number, then it is unbounded, or we call it divergent series. All right. So divergent and convergent we study later in college, not here. So these terms are not required here. Just understand the meaning of it. So this is a convergent series. Convergent means its summation will approach to a finite number if common ratio of a GP is less than 1, magnitude wise. That means it can be minus 1 by 2 also. So whether it is plus 1 by 2 or minus 1 by 2, plus 1 by 3 or minus 1 by 3, or 2 by 3 or 5 by 10, whatever you want to take, or 5 by 9, something like that. Then what will be the sum of infinite series? Then you can say this AR raised to n, this you were seeing, right? This term was approaching to 0, close to 0. Even this is 2 raised to 100 is still significant, although it will come like decimal. You'll have to write, if you write it in places of decimal, then it will be like after 10th or maybe 15th place of decimal, you'll get a non-zero number. So AR raised to n approaches to 0 when n approaches to infinity and mod of R is less than 1. So sum of infinite terms. Now this is the concept, and after I'll prove the formula, I'll tell you the formula, then that will be very easy thing to apply. That means easiest of all the series, easiest thing to find in all the series. Okay, so sum of infinite series of GP will be, so what was the sum of n terms? That was A into 1 minus R raised to n upon 1 minus R. This was the sum. Now this term will approach to 0 because I have written it here, but R is not 0, R is significant. AR raised to n will be 0, right? Will be very, very small, so you can ignore that term, and it is going to be now sum of infinite terms is written as A. Now this term will become 0, so you'll get A only in the numerator upon 1 minus R. All right, so that will be the sum of formula for sum of infinite terms of a GP. All right, so remember that sum of infinite terms, like if I write a series 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube, you can see this is a GP, and you can take this infinite sum of, you can find the infinite sum of infinite terms of this GP. Okay, so that is written. So sum will be, as infinity is, first term is 1, so 1 upon common ratio you can see is 1 by 2, divide second by first or third by second or fourth by third, so common ratio is 1 by 2, apply that, and you can see this series is converging to 2. Sum of this series is converging to 2. All right, so this was the formula of infinite. Even if you have arithmetical geometric series and common ratio is less than 1, the same logic will be applicable there also, which I have explained here. In that also terms, when n is becoming large, term will approach to 0, and there also that series will converge. Arithmetic co-geometric progression, in which you multiply one arithmetic and one geometric progression. All right. So I hope it is clear. Now let's do some problem. Okay, try this one. Answer it. Extremely easy problem. Apply the formula. Find the sum. Let's finish it fast. Answer it fast. Okay, done. Yes, A. Okay, A, you guys are getting A. Yes, the first term is 1 and common ratio is nothing but 1 by 3. Yes, so apply the formula. Sum of infinite terms is A upon 1 minus 1 by 3. So absolutely correct, but this was very easy problem. So this is going to be 1 upon 3 plus 1 upon 3. So 3 will come in the numerator. Yes, it is 3 by 4. Well done. Now try this. And this type of problem was there in the JEE main this year, which happened just now. Exactly similar problem, exactly similar. Some number was there like 0.64. I think number was also 0.64. And same type of GP was written inside the log. And log was in the power. Okay. So exactly similar problem was there in JEE main exam this year. Just now, which happened in September. It was 3rd September's paper, and I solved that paper. I have solved that paper. I have given the analysis on the same channel. You can watch that. That has that analysis. I mean, I have discussed that paper, so you can see that video, and it is there. It's 3rd September's first shift paper of JEE main. That paper had the similar problem in the exam. Okay, so this is a good problem. Solve it. Find the answer. Find the answer. All right, so Subhash, you got B. Okay, let me solve it fast. So you can find the sum of this GP separately. So it is 1 by 3 plus 1 upon 3 square and 1 upon 3 cube is nothing but A is 1 by 3 and common ratio is also 1 by 3. Common ratio is also 1 by 3 upon 1 minus 1 by 3. So it is going to be 1 by 2. Then take log of 2 means 1 by 2, and this is written 0.25 is basically 1 by 4. You can write, and then you can write log of 1 by 2 to the base 1 by 2 is square, and you know how to tackle this power. Take this outside the log, so it will be 1 by 2 outside. This power will come in the denominator outside. Okay, so 1 by 2 log of 1 by 2 to the base 1 by 2, and it is going to be 1. So this is 1, and yes, this value is 1 by 2. So y is 0.64 to the power 1 by 2. Okay, so we have got the value of this whole thing, which is 1 by 2. So you need to take square root of 0.64, and yes, it is 0.8. So your answer is correct, Mr. Subhash. Point 8 is the correct answer. Well done. All right. So we'll finish today's session. That's it. We'll continue tomorrow. Okay. Not tomorrow. Yeah, tomorrow. Geometric progression tomorrow will continue, and we'll do problems based on summation. So we'll discuss a lot of series of geometric progression tomorrow, and it will be an interesting session. This was easy today. Today it was very basic. Okay. So try to memorize all the formulae which I have told you, all the important points which we are going to practice tomorrow. All right. Okay, well done. Thank you. Thank you very much. Like and subscribe my videos and like the channel. Subscribe the channel. All right. Thank you. Back to Let's Crack. Hello everyone. Welcome back to Let's Crack JEE in English, the channel of Unacademy. And I am Jeetendra Dixit. I did my BTech from IIT Kanpur, and I have been mentoring IIT-JEE aspirants for last 11 years. So today we are going to discuss indefinite integration practice session. Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. And I am Jeetendra Dixit. I did my BTech from IIT Kanpur, and I have been mentoring IIT-JEE aspirants for last 11 years. Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. And let me start with my introduction. So I am Jeetendra Dixit. I did my BTech from IIT Kanpur, and I have been mentoring IIT-JEE aspirants for last 11 years. I have worked with various national level institutes in Delhi, Mumbai and Lucknow. So we were discussing in this session, we were discussing integration, and we have already completed the topic, and one practice session has already been done. So this is the second practice session of miscellaneous problems of this topic. So I'll discuss a lot of problems today. But before the beginning, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform, and you can prepare for many exams on this platform. But here, let's talk about IIT-JEE. So if you get the subscription for IIT-JEE, then what are the things you get on Unacademy? Let me tell you all those things. But before that, let me check one thing. All right. Fine. Okay. So when you get the subscription for IIT-JEE, then you get access to daily live classes of all the JEE educators, all means all physics, chemistry and maths. And you can attend their live sessions, and you can interact with the educator during the live sessions through chat. You can ask your doubts, and there are dedicated sessions for doubts also. During the live sessions, you can ask your doubts. You can chat with, you can participate in the poll. Polling is a very interesting option, and hello everyone, welcome back to Let's Crack JEE in English, the channel of